Hey everyone, so this is a quick review, quickish review of variation. I'm assuming you've seen it once before. Okay, variation, when we talk about variation, there are three main types of variation: direct, inverse, and joint. So I'm actually just going to go ahead and put these on the screen. I want to just point out k is the constant of variation. First, let's just read through these and then let's kind of break down the patterns. So what I want you to do is I want you to think of what patterns do you see as we go through this. So direct variation. So y varies directly with x means that y equals kx. Inverse variation. Y varies inversely with x means y equals k over x. And then finally joint variation. Y varies jointly with x and z means y equals kxz. Okay, so variation is telling you basically like an equation type that has a k in it and what to do with the k. So a couple of things to point out here. With the k, so I always say I have the memory of a hamster. And so I'm always like, oh, what if I forget where the k is? The k is always like on top. It's always on top of the equation. So kx, k over x, kxz. So k is always there. So variation always has this k. It's just assumed, okay? And then the other thing, just as far as like ordering goes, you can think of the term y varies. So notice y varies, y equals, y varies, y equals, y varies, y equals. So sometimes you'll be told these equations without a y and an x, but the concept of something varies is going to give you this like what the what the letter equals. I'm stumbling over my words. All right. So there's a little bit of a pattern to all of this. And then really the last thing that you need to know is like what is happening to the k. So direct means directly with x means multiply by x. Inversely with x means divide by x. Jointly with x and z means multiply by both. So that's variation in a nutshell. If you crack that code, I think it's much more straightforward. And mathematically, like usually what you're being asked to do with this, it's not terribly difficult. There's also combined variation, which means that you use two of the previously discussed types. So you take direct and inverse or inverse and joint. We'll see some examples of that in a moment. Okay, so if y varies directly with x and y equals 15 when x equals 3, find y when x equals 6. So this is like your classic variation type problem. So let's outline the steps. Step 1. Write the general variation equation, which is given by this. Y varies directly with x. So what is the format of the equation? In this case, that would be y equals kx. That's what that means. Okay, so next, we want to plug in the given info to solve for k. So that's in this information right here. So I have y equals 15 and x equals 3. So if I just plug that information in, I have 15 equals k times 3, which I could really think of as 15 equals 3k. So if I divide both sides by 5, I will get that k equals what? K will equal 5. So you want to solve for k, and then I'll just write down the step. So using the k that you found in part 2, finish the problem. So this last piece of information here, find y when x equals 6. So what I want to do is I want to write y equals, so now k, instead of writing k, I'm going to put in a 5. And then, so remember, we had y equals kx. So I put in a 5 for the k, and now x equals 6. So I just plug in 6. So what is y? Y is going to be equal to 30. So there you go. Okay, so for another problem, so if a varies jointly with b and c, and a equals 40 when b equals 2 and c equals 5, find a when b equals 3 and c equals 2. So I'll outline this with you. So what I want you to do is first just state the general variation equation and then solve for k. So see if you can do that. Just pause the video here. Remember, math is not a spectator sport. You'll learn more out of this if you engage. And then hit play when you think you've got it. So my general variation equation is a equals kbc because it's jointly. So I multiply by b and c, and then I can put in the information. 40 equals k times 2 times 5, which gives me 40 equals 10k. So if I divide both sides by 10, I get k equals 4. So now I've used up all the first pieces of information. So if you got to this point, now I recommend that you just finish the problem and hit play when you're ready. So now I want to find A, so I'm going to plug in my k equals 4, B for 3, and 2 for C. And so then let's see, that's going to be A equals 24 in that case. So we're done. Okay, so next we have just a slightly more complicated looking equation. This is with combined variation. P varies inversely with m and directly with the square of t. And p equals 32 when t equals 2 and m equals 4. Find p when t equals 3 and m equals 9. Okay, so I will tell you that you just have one single k in this problem. I think you should pause and just write down what you think the general variation equation is before I tell you. So just pause and try that. So the general variation equation, so we have 1k. So p varies inversely with m, so that means I'm going to take the m and divide it, but then also directly with the square of t. So that means t squared. Directly means multiply k by something. So this will be k times t squared. There's your general variation equation. So even if you got it wrong, like hopefully now this makes more sense. It's always better when you take a second to think about it. Okay, so now what I want you to do is solve for k and hit play when you're ready. So I have 32 equals k times 2 squared over 4. So I literally just plugged in the numbers 32, 2, and 4. So here's where I'm at. So if I try to solve for this now, I get 32 equals k, so let's see, this becomes really 4k over 4. So the 4's actually drop out in this case. So my k is actually just equal to 32. So then when I'm asked to figure out the last part, find p when t equals 3 and m equals 9. So now if I plug those pieces in, so I have p equals, I'm going to plug in the 32 for k. Remember to square your t and then divide that by 9. So interestingly, I get that this will just equal 32 again, because the 9's will drop out. It's actually just the same number again. So sometimes people forget to plug in the, like, or to have like the squared term. So this is the square of t. If you wrote square root, it would have said the square root of t. So square versus square root, they're two different operations. It's literally the same as saying t squared. Okay, so the last thing I want to talk about here is just recognizing when variation comes up. There's a lot of situations that actually use variation. It might not be immediately obvious, so let's look at some examples. Okay, so the first example, I want to rewrite this as variation. So c equals 2 pi r, where c is the circumference of a circle and r is the radius. Okay, so instead of thinking of this formula, so remember I've got c equals. So in the language of variation, I would say c varies, and then we're multiplying, right? So we're multiplying by r. So c varies directly with r. And now you might be saying, wait, but what about the 2 pi? In this case, the 2 pi, so the 2 pi in this equation, this is actually equal to our k. Remember, it's the idea of a constant, and so 2 pi is always in that formula. So that actually fulfills exactly the definition of a constant of variation. Okay, so next, r equals d over t, where r is the speed when traveling d miles over t hours. Okay, so now in this case, we have two variables, so we need to represent both of these in our variation. So since, let's see, so first of all, where do we start? We start with r varies, right, since it's r equals. Now, since both letters matter in this variation equation, we're going to say that it varies directly as d. That's how it would end up on top. and inversely as t. And now you might be saying, but where's the constant of variation? So the constant of variation in this case could have been just equal to 1. If you don't have an actual constant number, as we did in this example, then don't worry about it. You want to just make sure that you're calling out each variable that you see in the equation. So I need to make sure directly as d and inversely as t. That will allow me to make sure I've hit all the variables I see in the equation. Okay, so let's try this one more time with c. Using what you know now, so you need to write a variation equation that will represent all of these variables. So maybe you want to pause here, try this, and then hit play when you're ready. So we have F equals mv squared over r, where r is the centripetal force of an object of mass m moving along a circle with radius r at velocity v. Okay, so now since I have mv squared on top, that looks like joint variation to me. So this would be F varies jointly as m and the square, right, of v and inversely as r. So that again would allow me to cover all my bases and hit all those variables. Maybe the k in this case would then just come out as 1 more time. Okay, and so that brings us to the end of this video. I have another video where I go through some examples of variation, so be sure to check that out if you need more help. And otherwise, I will see you guys in another video. Thanks for watching.